This is the Almost Timely newsletter for the week of October 20th, 2024. Content authenticity statement. 70% of this week's newsletter was generated by me, the human. You're going to see a lot of outputs from AI in the opening section of the newsletter, detailed by which AI they came out of. There's a link at the top of the newsletter to understand why this sort of disclosure is important and might be legally required, depending on where you do business. The big plug this week got a brand new guide. It's like 10 pages long or so on prompting generative AI for image generation. So tools like Midjourney, Flux One, Meta AI, Google Imagen, and DALL-E, OpenAI's DALL-E, how to prompt these things for good results and some starting prompt templates. So grab the guide, totally free. You do have to submit your information, but there's a link at the top of the newsletter in the big plug section. All right, what's on my mind this week? Advanced prompt engineering for generative AI. After last week's newsletter covering intermediate prompt engineering, a half dozen of you or so emailed back to ask what advanced prompt engineering looks like. And in at least one person's case, a deep burning desire to see it. That may or may not be an exact quote. So be careful what you ask for. Advanced prompt engineering tends to go in one of two directions: scale and complexity. So with that understanding, let's go down the rabbit hole of advanced prompt engineering. Part one, what is advanced? What do we mean by advanced? Here's my big warning. Advanced doesn't mean better. Advanced does not mean better. Let's start with that. Advanced means you're facing problems and tasks that you couldn't solve with beginning prompt engineering or intermediate prompt engineering, that you couldn't solve simply. You've got bigger problems, more complicated problems, and so you need more complicated solutions. Generally speaking, simple is better than complex. Solving a problem simply tends to mean it's more straightforward to solve, to maintain the solution, and repair the solution if it goes awry. The more advanced something is, the more complex it is, the more likely it is to break in a bunch of different ways. And the more brittle the solution is, the more energy it takes to maintain the thing. We have kind of a love affair with the word advanced. So it's super cool. And this is a problem that I see a lot in the martial arts. Folks want to do advanced techniques, black belt techniques, 5th degree black belt techniques, master level techniques, not realizing those techniques aren't better. They're not better. They're not faster at solving the problem. The advanced techniques are for when everything has gone to hell and your bread and butter tools do not work. You punch the guy and he's still like, what else you got? You're like, well, I guess we better get something else out of the toolbox. Ideally, your simple techniques work great. When you look at the martial arts and people who are legitimate masters of the martial arts, expertise, true experts, they are more typified by being able to do the basics really, really well in very creative ways, under a lot of pressure, and in a wide and wild variety of circumstances, right? You present them with a crazy scenario. Hey, here's 15 guys with spears. And what do? Well, they do their basics against 15 guys with spears. That's advanced. That's what people are thinking of when they think of advanced. When we're talking about techniques, the more complex a technique is, the more ways it can go wrong, especially under pressure. And so advanced techniques are not something you want to spend a whole lot of time on. They're for when things have just gone sideways. Cue all of the martial artists like me who, a dozen years after I got my white belt, which was 1993, are deeply disappointed that being a black belt wasn't nearly as cool as we imagined it being. I remember after I got my first degree black belt, I was like, this is awesome. I got my black belt. I'm ready for more advanced techniques. And the more advanced techniques are either get better at the basics, or, hey, here's a weird situation that you might run into, and here's how you deal with it, but you're not going to run into it that often. I remember at one martial arts event I was at with an advanced teacher in our art, they showed the advanced, the secret scrolls. And we looked over these things and we're like, what the heck does this even say? And the teacher's like, well, this is for a very specific scenario that this very specific group of people ran into, fighting on small, crappy boats in the 14th century. It's considered a secret because that was how that school of martial arts and that family dealt with their problems dealing with pirates on the coast of Japan. It has no relevance to today. Right? Those techniques really, yes, they are advanced, they are secret, but they're kind of useless now. The same thing is true in AI and prompt engineering. If you look at some of the academic papers on prompt engineering, many of the more advanced techniques are edge case techniques that have very limited application outside of a very specific kind of problem. You look at the problem like, oh, okay, this is the problem that we're trying to solve. And you're like, but I don't have this problem. Let me show you an example. Let's go ahead and change screens here. This paper is called Program of Thoughts Prompting. Let's go ahead and make it a little bit bigger. Program of Thoughts is a very specific prompting technique where you have a tool, you have an AI tool, generate pseudocode in a language, even if it doesn't run the code, to try and solve a problem mathematically better. Right? Specific domain use is solving mathematical problems by combining non-running code generation with chain of thought prompting, which we covered in last week's newsletter. This technique has very little use in most domains of generative AI. Most people are not going to use it. It doesn't apply to their situations. It's an advanced technique. But unless you have that specific problem, it's not going to be helpful. It is for handling edge cases and mathematical word problems. Is it advanced? Yes, in the sense that it's not something a beginner needs to know to be effective with AI. Even an intermediate user would have very little use for this most of the time. If you want to be advanced in your use of prompt engineering and generative AI, if you want to be seen as an expert, as an advanced user, the same thing is true in the martial arts. Get really, really good at the basics in a wide variety of contexts. Maybe that's a topic for a future newsletter, what the modern basics are, things like model priming, things like metacognition and stuff. Maybe that's a separate issue. If that is of interest, let me know. Just reply in the comments. Part 2, scaling prompts. So with the perspective of what advanced really means, which is things that aren't working as well, let's look at one of two branches of more advanced prompt engineering. The first is scaling prompts. Very often, we can write a prompt to do a specific task very well, like sentiment analysis or topic classification. For example, we might write a prompt to categorize a blog post. So let me pull this up here so that we can see it on screen. Right, this prompt exists to classify a blog post based on a topic or a category, given a list of existing categories. So we see on screen here, objective, your task is to categorize, take a blog post and categorize it in one of these categories: cats, dogs, AI, ranting, math, and marketing. You're going to receive a single input, a blog post. You're going to spit out a JSON object as its output, and here's how to do it. Now, I will say, by the way, it's important to note this prompt is optimized for the Gemma 2 model. So don't go copying and pasting this into other systems. It's not going to work as well. I can guarantee you it will not work as well in different models like Gemini or ChatGPT, because this is very specific to the way Gemma works. This is an effective prompt. This is a good prompt. But a blog is not just one post, or if it is, it's not a very good blog. A blog is dozens or hundreds, maybe even thousands of posts. Can you use generative AI to classify them all? Not all at once, no, at least not with any reliability. You need to hand each blog post to generative AI and have it classify it and then store the results. The prompt is important because the prompt is how it does that, but it's not all that you need. It means coding. Typically in a language like Python or R or Ruby or any modern computer language. You need infrastructure around your prompt to get the blog posts from where they live, to hand each post to the generative AI model one at a time. Here's a post, classified. Here's a post, classified. And then to store the results. All of that is outside the scope of generative AI, of large language models, and well within the domain of traditional programming. Now, generative AI can still be helpful by helping you write the code to do this. But this is what I mean by advanced prompt engineering, taking our basic prompt, which is very good, uses all the basics, and deploying it at scale, scaling it up, making it bigger. Not by making a more complicated prompt, but by needing a system to house the prompt in the same way that an engine of a car needs the rest of the car. Things like looped tasks, control loops, and structures, data storage are all well outside the domain of generative AI, but are essential for solving this task. Part of the reason why AI is not showing the promised benefits at many companies is exactly this. It's not being used at scale. People are using generative AI very manually. I talked to a group of people recently at a conference not too long ago. They're having team members manually copying and pasting content in and out of ChatGPT. I mean, that works, but it is incredibly inefficient. Code would allow that process to be automated, to scale it, to get those benefits of not needing humans to do that part, the copying and pasting, right? Which that's just not a human job anyway. Scale is how we derive benefit from AI, taking problems and solving them not only fast, but in vastly greater quantities. It should not take a team of 10 people to copy and paste every blog post into your blog to classify it by topic, right? And take 7 days to do it. That task should be done in 7 minutes by a machine. Scale is how we get benefit out of AI. The challenge for people seeking to become advanced AI practitioners is scaling often requires skills outside AI, like programming, like IT, infrastructure, knowledge of data storage and data engineering, all the rest of the parts of the car. And if you're good at AI, that's great. You should want to be good at AI if that's going to be your thing. But you also need to know how to build the rest of the car if you want to be an advanced practitioner. And by the way, as we talked about not too long ago, AI agents and agentic AI is just a fancy term for building apps around AI. Not to take all the wind out of the hype, but an agent is just a piece of software around AI. Be cautious of AI point solutions, companies that are little more than a wrapper around AI. They made some infrastructure and took somebody else's model and built a company around it. That's fine, but as you level up your AI skills and start learning how to provide the infrastructure needed to scale AI, you're going to find you don't need to invest heavily in all these different AI agents and apps and companies. Not when you can build your own. You can fire up Claude or ChatGPT or Gemini and say, hey, help me build this thing. How do I build this into a SQLite database? How do I build this with a UI or a web interface? How do I serve this up? How do I turn this into an API? I did that this past week. I said, hey, I made this thing. I want to turn it into an API. What do I need to do? I've never done this before. The tool I was using gave me a nice blueprint, and I tried it. I'm like, that was way easier than I thought it would be. It's like 5 pieces of software, all in Python. Super simple. And so now my gears are spinning about what to do about that. Anyway, part 3, more complex prompts. So we talked about scale. Now let's move on to prompt complexity. Another aspect of advanced prompt engineering is knowing how to build more complex prompts for when simple prompts can't get the job done. Or again, this is not because they're better. It's because what you were doing isn't working as well. And there's 3 specific techniques to look at: code structures, reflection and reward functions, and model adaptive prompt optimization. Code structures are when we use coding techniques within prompts, not writing code itself, but using concepts borrowed from coding. Why? Because generative AI systems, language models in particular, have been trained on both the written word, normal prose, and code. They are fluent in interpreting the written word as code and vice versa, which means that control structures from coding are executed as though they are code, even if they're written in plain language. Here's a real simple explanation of what I mean by this. Let me pull up my screen here and show you this silly little prompt. Now, I am intentionally omitting a bunch of key best practices here, like the Trust Insights race framework for role declaration, the priming of the model with the Trust Insights pair framework. This is just a toy example. It says, if this tweet is factually untrue, then write a response telling the author how the tweet is untrue and citing a source of truth, else write a response thanking the author for their contribution. Now, this code would not run in any programming language in the world. None of them will run this, but it absolutely will be executed by a large language model as though it were code. And you and I can read it clearly and easily, understanding its intent. If we want to try this for fun, let's do this. I'm going to say, follow these instructions. Here is the tweet. And let's do something that sounds semi-realistic, but is completely untrue. The United States is in worse shape than ever, as there are more lizard people aliens masquerading as ordinary citizens, undermining our country. Right? It's ridiculous. But in the interest of avoiding real life politics, we want to go with something silly. Let's go ahead and bring up. Let's do Google Gemini, and I'm gonna just paste this in. Now let's see what happens. Google Gemini says, the tweet is factually untrue. There's no credible evidence to support the existence of lizard people aliens, let alone that they're undermining the United States. This claim is often associated with conspiracy theories. You can find more information about this. So that tweet is patently untrue. Let's do a variation of this. The United States is a happier place than ever thanks to cleaner air and water, which is scientifically true at the moment. Let's try this in a new chat. Okay. The tweet is factually untrue, but the United States made strides. Happiness levels are influenced by many factors and haven't necessarily increased. Okay. Well, that is also true. But that was not what I was going for. Anyway, you get the idea. You can read that code, right? You can clearly understand it. You understand its intent. You could modify it. Code structures are fantastic in generative AI prompt engineering because they allow us to formalize the kinds of decisions we want language models to make as they process our data and follow our instructions. Think of the basic code structures we know from coding, from programming. If else, right? If this, then that. It's a primitive decision tree. Those examples we just looked at. If, then else. While, a while loop. Until a condition is met, keep doing a thing. While this is true, keep doing this thing. A for loop. Given a certain set of conditions, keep doing a thing for the duration of those conditions. For I equals less than 7, do this thing in increment I. Case when statements are a more advanced decision tree with multiple options and outcomes. Now, why does this matter? Using code structures in our prompts makes our intentions clear to the language model and to ourselves. They're easily readable, easily understood, and easily modified, even by people with no experience coding or prompting. You use code structures when you need sophisticated decision-making in a prompt. Second technique, reflection and reward structures. Much was made of OpenAI's announced O1 preview model and how it's supposedly the future of AI. A lot of that's hype. At its core, O1 bakes in 2 key mechanisms, reflection and reward, and it uses chain of thought, which we talked about in last week's issue. Reflection is when we ask a model to think about what it's generated and evaluate whether or not it's done, what it created meets the goals of our prompt. Think about what you've done. Reward is when we have a model keep score to know whether or not it's getting closer to the goal or further away, and to adjust its strategies based on the reward. If we think about the average sports game, right? Baseball or football, American football. We see these two mechanisms all the time. After a period of time, like an inning or a quarter, the coach talks to the players, reflecting on what worked, what didn't work in that time period. It's reflection. The score on the scoreboard, it pretty clearly indicates how well or poorly the players' efforts are working. If the team is losing, the coach knows they need to change strategies as long as the coach is good at what they do. They can say, hey, it's the end of the first quarter, we're down 14. We got to change this, this, and this because it's just not working. That's what reflection and reward is. It sounds fancy. It's not fancy. Here's the thing. OpenAI's implementation is not unique. Right? You can perform the same set of tasks with prompting on pretty much any capable foundation model. Anthropic's Claude, OpenAI's GPT-4o, Google's Gemini. What makes the O1 model notable is that you aren't given a choice. Right? It does this set of tasks for you. It does reflection and reward with or without your approval, which is good if you have people who are used to writing poor and insufficient prompts. If you're good at prompting, you'll be an incremental benefit. So what does a reflection and reward structure look like? And what if we had to build one, what would it look like? Well, it would look, let me pull mine up here. Let's go ahead and there we are. And we'll scroll down. So it'll be below this line here. Let's take our toy example, and we're now going to say we define a truthful statement as one that accurately reflects reality or facts as they are currently understood without any intention to deceive. Read the following tweet. Think through step by step how truthful a tweet is. Score 0 to 10 how truthful a tweet is based on a definition. That's the reward function. Reflect on your evaluation. Evaluate each part for step 2. Make a judgment on the truthfulness of the tweet. Here's our case when statement. When the score is 0 to 3, the tweet is untruthful. When the score is 4 to 6, the tweet is somewhat untruthful. When the score is 7 to 10, the tweet is truthful. Reflect on your judgment. How accurate do you believe your judgment to be? Score your judgment. See, this is reflection and reward. These are loops. While your judgment score of your effectiveness, I should say, is less than 8, restart the process of scoring the truthfulness of the tweet. Once your judgment score is greater than or equal to 8, if this tweet is truthful, then write a response telling the author how the tweet is untrue and citing a source of truth. Else, if this tweet is somewhat untruthful, then write a response telling the author what additional sources they could investigate. Else, write a response thanking the author for their contribution. So let's give this a spin. I'm going to start with our lizard aliens again. And let's go into Google Gemini. Start ourselves a new chat. And let's watch our reflection and reward structures work. Read the tweet. Think through step by step. Premise 1, the United States is in worse shape than ever. This is subjective and depends on the metrics used to assess the shape of the country. There's no objective truth statement. Premise 2, there are lizard people, aliens, citizens. There's no scientific evidence or credible reports to support the existence of lizard people aliens. Premise 3, the lizard people are undermining our country. This builds upon the previous false premises, therefore is also untrue. Score 0 to 10, how truthful the tweet is. I would score this tweet a 1 out of 10. Reflect on your evaluation. Evaluate each part. The first premise is an opinion or a fact. The second premise is demonstrably false based on current scientific understanding. The third premise is illogical and relies on the second premise being true. Make a judgment on the truthfulness of the tweet. It's untruthful. Reflect on your judgment. How accurate do you believe it to be? I score my judgment 10 out of 10. The tweet's claims are easily verifiable as false. Here's a possible response to the tweet. This tweet promotes a harmful, unfounded conspiracy theory. There's no evidence to suggest that the lizard people exist. Right? So we can see how this reflection and reward, how this response is different from our previous one, right? So this is what it came up with previously from that simple if then. Now we have a much more thorough response that even the how it responds is more thorough. Now I'm curious. Now we're going to take that environmental statement that it spit back last time is untruthful. I'm going to run the exact same thing, and I'm really curious to see how this is going to turn out. All right, here we go. The United States is a happier place than ever thanks to cleaner air and water. Think through step by step. Cleaner air and water. While environmental regulations have led to improvements, these improvements are not uniform across the country. Some areas still struggle with pollution. Happier place than ever is a complex issue with many contributing factors, including economic security and so on and so forth. It's difficult to definitively say whether the U.S. is happier than ever due to cleaner air and water alone. Correlation versus causation. Even if people are happier in areas with cleaner air and water, it's not necessarily true. Score 0 to 10, how truthful the tweet is based on a definition. I would score this a 4. Reflect on your evaluation. I think my assessment of environmental improvements is accurate. Connecting happiness solely to environmental improvements is a simplification. Highlighting the difference between correlation and causation is crucial for nuanced understanding. Make a judgment based on the truthfulness of the tweet. I judge this tweet to be somewhat untruthful. Reflect on your judgment. I score my judgment an 8. Response to the tweet. While cleaner air and water are definitely positive developments, it's a bit of a stretch. So here are some resources to get started. The World Happiness Report and so on and so forth. Now, compare this response to this one here where it said, nope, untrue. You can see how the reflection and reward functions, combined, by the way, with the control structures, creates a better outcome. Right now, we've continued to omit those best practices, the race and the paraphrase, for brevity. Otherwise, this newsletter would be dozens of pages long. But you can see the reflection and rewards within a prompt and the code structures used to make explicit what it is we want the machine to be doing. And the results are really good. The results are much better by using not just the control structures, but also the reflection and reward functions. Now, why does this matter? Reflection and reward structures are part of prompt engineering. They're part of a discipline called metacognition, which is thinking about thinking. The more time and room a model is allowed to have to think things through, the better its performance tends to be. We just saw that. We have the short little prompt, the short controlled structure gave short answers. The long one where we told it, hey, think this through, gave a longer answer, but it gave a better answer, right? Performance improves with length. This is because of the probabilistic nature of language models. The more relevant words there are in a conversation, the easier it is for the model to predict the next set of relevant words. I say this in my keynotes all the time. The more relevant specific words you use, the better the performance is. Well, this is not only true of you and your prompts, but also of the machine and its prompts. The more you encourage it to use relevant specific words by asking it to think things through, by reflecting on its choices, by giving itself rewards for doing the task well, the better its performance will be. Reflection and reward structures give it the ability to be verbose in a focused way, relevant, and change strategies when the words it's outputting aren't as aligned with the instructions. Using reward and reflection structures properly can dramatically improve a model's performance. So much so that OpenAI thought it was worth building an entire model with these practices built in that's 30 times as processor intensive as its current state-of-the-art model. That's how big a deal they think this is. The third and final advanced prompt engineering technique for today is called model adaptive prompt optimization. This is fancy for tailoring prompts to work with specific models in the way that they work best for those models. This becomes critically important once you start using open models and local AI, where the models are typically smaller and less capable than the big foundation models. Open models do run on consumer hardware, though, and they're ideal for when you're working with highly sensitive data that can't be in third-party hands for any reason, like protected healthcare information, national security, financial secrets, etc. Model adaptive prompt optimization is a type of meta prompting where we have a model rewrite a prompt that works best for it. We take our toy example above and ask different systems to customize it for them. We will end up with wildly different prompts depending on the model, but each prompt is going to be optimized for that particular model and how it works. So let's do an example. Let me get my environment set up here. We'll start with our old buddy ChatGPT. And I'm going to take this set of instructions that we were just using, and let's slot it into our prompt engineering meta prompt. We're going to say, hey, convert this for ChatGPT. Let's paste it in. All right. Let's take a look at, wow, it really went haywire on that first example. But here's the existing example. So we have system instructions for evaluating and responding to truthfulness of tweets in a multi-step process. Objective, definition, step-by-step instructions, accuracy, reflection loop, response generated on the final truthful. And you can see there's our control loops. Additional instructions, summary of key conditions, process completion. That's pretty good. Right? That is pretty good. So let's now put this to the test. And where's my lizard people tweet? Let's take ChatGPT's great big system instructions here and our tweet and put this in and see how well it runs. I love this lizard people stuff. That's so funny. Score truthfulness of 1, judgment overall truthfulness, accuracy score 9. Here's the response. So it did a really good job, but you can see how big a difference this is from our original code. And when you look at what ChatGPT spit out, this is a very different way to write this. Now, let's do the exact same thing, but we're going to customize it. Instead for ChatGPT, we're going to customize it for Mistral Small, which is a French model. Well, it's made by the Mistral company in France. It's an open model. And so I'm going to put this into the Mistral architecture that we're using Cobalt CPP to host it. And this, by the way, is fun to watch. You can actually see it making its decisions alongside. So here's a complete set of instructions. Oh, I need to change the output. It does not have nearly enough room to run. So let's take this. So this model has a context of 32,768. And the maximum output, let's do 4096, 4,000 tokens. Temperature looks good. Reputation looks good. Let's retry this. All right. And you'll be provided with a tweet. Your task is to evaluate the truthfulness using a multi-step process. Understand the definition, read the tweet, step-by-step truthfulness evaluation. Scoring truthfulness. All right. Now let's take. So there's our. And just for fun, as we did with ChatGPT, let's take our our tweet. Example process. Good. All right. I'm going to copy this set of instructions because I want to preserve this for later. Let's go ahead and put that in Mistral Small. And now let's put in our lizard people. No, we need to put the system instructions into Mistral Small. So let's do that. Let's get the instructions into our context window. There we go. And go. Oh, what happened there? I did not copy those instructions properly. All right. I'll come back to that later. So we can see what a huge difference there is between these two systems and models and how a starting prompt can be optimized for specific infrastructure. And we covered this in last week's newsletters in an intermediate technique. And when you use it like this manually, it absolutely is. Right? Anyone can say, hey, rewrite this prompt for me. But this is the starting version. For very small models that don't have meta prompting and metacognition skills, typically models under 10 billion parameters like Llama 3.18b or Gemma 2.9b, or absolutely mission critical prompts where there is no room for error. There are frameworks. There's one called DSPy, but there's a bunch of these different frameworks that can do the prompt optimization programmatically, assuming you can get the technology set up and you have a stockpile of good and bad questions and responses to train with. And you load the framework up with your training data, pointed at the model of your choice, and then it pretty much tries every variation of the prompt to get to the outcomes you provided. So comparing, hey, here's the prompt, here's the response, how close is this to the training data? And then it rewrites the prompt over and over and over again. This process can take hours, even days, depending on the complexity of it, and can be exceptionally costly because, again, you're trying every possible variation of a prompt. But for those edge cases where a model's output must be reliably in a certain format or output 99% of the time, this is how you approach it. That's what makes it advanced, is you have a prompt that absolutely positively cannot be deviating from the instructions you give. So you have to put it through this rigorous test and get it tuned up. Now, why does this matter? Advanced prompt engineering is all about solving problems that our basic skills couldn't. Maybe we couldn't get a model to do exactly what we wanted, or return data in exactly the format we asked for, like JSON notation. To mitigate those problems, we use techniques like model adaptive prompt optimization and some of the infrastructure around it to get exactly the results we need in mission-critical scenarios. Part 4. Do you need to be advanced? Let's wrap up by answering this question. How advanced do you need to be in your prompt engineering skills? The answer to this question will vary wildly and be dependent on the kinds of problems you're having today. If you are accomplishing everything you want and achieving the results you need to achieve with generative AI, with the prompts you have today, you probably don't need more advanced techniques, right? If you're not running into situations where things are just going sideways, you don't need more advanced techniques. What you're doing is working. Now, it doesn't hurt to learn them, but they're not going to be your bread and butter. Think of it like transportation, right? The bigger and more powerful the vehicle, the more complex and expensive it is to operate. Walking is free. Riding a bicycle has some costs, but they're relatively low, and a bicycle extends the range that you can go at. A car, much more powerful, but much more expensive. And a Harrier jet, absurdly expensive, but crazy powerful. What do you need to go to the grocery store? If you live in a big city with great public transit, you can probably manage with your feet alone. You may not even have a place to park a car, and you certainly won't be keeping a Harrier on your apartment rooftop. Likewise, if you live in northern Sweden in the middle of Australia, a Harrier, a plane, might be a reasonable means of transportation because it's hundreds of kilometers to the next town. The same is true of AI models and solutions. Fit the tools and technologies to the problems you're solving. You don't need reflection and reward structures to summarize an email unless the email is some bizarre edge case. You don't need a big foundation model like ChatGPT to draft a memo response, right? And you certainly don't need to spend hours and hours optimizing a prompt for an unimportant task you'll do maybe once. Using advanced prompt engineering techniques just for the sake of using advanced techniques is usually rooted in ego, in the same way that an egotistical stage magician makes their magic tricks unnecessarily complicated and flashy to impress other magicians. Instead, as with the martial arts, get really good at the basics and then grow your skills from the specific problems you're trying to solve that the basics don't help with. All right, what else happened this week in the news? In addition to all the articles on the channel this week, we had a great live stream doing a bake-off of different image generation utilities. And the guide I talked about at the beginning of today's newsletter stems from that. So you can watch the live stream, the on-demand recording to see how that guide's prompts are put to use. Also talked about conference materials and what to do with them, generative AI backup plans, and demonstrating the lineage of generative AI, and a really important piece on the problem with AI content detectors. This has been coming up more and more, and it's probably worth a separate show entirely about it, but they're problematic. All right, let's take a look at jobs this week. What do we have? We have business intelligence analyst at Omnicell, consumer and products insights lead at Quince, data analytics engineer at Tech Triad, digital analyst at Planet Interactive, director of data science at Movable Inc., head of AI at Harnum, manager of analytics at Merkle, marketing business analyst at Swipe Jobs, personal finance e-commerce editor at Kiplinger, Product growth analyst at PandaDocs, senior analyst at Angie, senior analyst at Dentsu, senior analyst at Hatch, senior business analyst at Descendian, and senior data analyst at Convey Health Solutions. A lot of analyst jobs this week, which is a good thing to see. Upcoming shows, I'm going to be at the Marketing Class B2B Forum here in Boston in just a few weeks. It's like 3 weeks away, I think now. Maybe it's 4 weeks, but that's coming up fast. So if you're going to be at that show, come on over and say hi. I'll then be doing a virtual event with AMA Houston after that. And then I think maybe one more thing. Then we coast into the end of year, and then we're back at it in 2025, which is crazy to say that. That is going to do it for this week's episode. Thank you for tuning in, and I'll talk to you on the next one. If you enjoyed this video, please hit the like button. Subscribe to my channel if you haven't already. And if you want to know when new videos are available, hit the bell button to be notified as soon as new content is live.